Before we dive into today's episode, make sure to hit that subscribe button. It's the best way to stay updated with our latest insights.
Ladies and gentlemen, welcome to the CTSS Academy podcast. The energy is electric. The crowd is alive. Let's dive into greatness. We're champions strong.
Before we start the show, don't forget to check our new ebook, Kill All Bugs, Learn Software Testing in One Day. For a limited time, it's only $9.99. Links in description.
Welcome back to the deep dive. Today we are going straight into the architecture of our digital world.
That's right.
Every device you use, every file, every website, it's all built on a hierarchy of connections. But, for most people, those acronyms, PAN, LAN, MAN, WAN, they're just a confusing mess of letters.
A real alphabet soup.
Exactly. So today we're giving you the shortcut. This deep dive is a clear, rapid breakdown of the four main types of computer networks. We're going to look at them by size and by what they're used for.
And we're going to focus on the trade-offs. That's the key thing here. Cost, speed, and especially security.
Right. So you can see where your own devices fit into this huge digital landscape.
Well, at its most basic, a computer network is it's a group of two or more systems that are connected. They use common rules, we call them protocols, to share things.
Files, resources, that kind of stuff.
Exactly. And that connection, it relies on hardware, software, and the media itself, whether that's a cable or just, wireless waves.
So this isn't just a list of definitions. We're analyzing the strategy behind them. Networks are really classified by the physical area they cover.
Right. From just two devices in one room all the way to millions spread across the entire globe.
And to manage that scale, we rely on the big four, as you called it: PAN, LAN, MAN, and WAN.
And we're going to move systematically. We'll start with the smallest, most personal network and then move outward, looking at how the cost goes up, speed changes, and how security gets a lot more complicated with every step.
Okay, let's do it. Let's start with the smallest bubble you can have. The PAN, or personal area network.
So a PAN is a network that's basically formed around a single person. Think about your computer, your phone, maybe a smart assistant.
Okay.
It's all about getting those few personal devices to talk to each other, or maybe just giving them a quick gateway to the internet.
We use this every single day without even thinking about it. Your cordless mouse connecting to your laptop, your Bluetooth headphones.
Pairing your phone to your car.
Right. The second those devices link up, that's your PAN.
And if it's all wireless, which it usually is, we call it a WPAN. But the real insight here is about security. PANs are, pretty secure.
And why is that? Just because they're small?
Pretty much. Their range is their best security feature. They are strictly limited to a very small area. We're talking about 10 meters max.
So that tiny distance is what makes it safe, but that's also its biggest strategic weakness, right? 10 meters it's a very tight box.
Precisely. It's a short-range solution, full stop. The only other real drawback is interference.
Yeah.
Because these devices use common radio bands, your connection can get choppy if other networks nearby are using that same spectrum, but really they're just convenient, isolated, and limited.
Okay, so if the PAN is our tiny 10-meter bubble, what happens when we need to share things across, say, an entire office floor or a whole building?
Well, that's when you need shared infrastructure.
Yeah.
And that brings us to the absolute backbone of modern offices and homes, the LAN, the local area network.
Right. So a LAN is a group of connected devices, but in a limited area, like a school, an office.
A home, a lab, yeah. It's so widely used because it delivers two critical things: high speed and, most importantly, total local control.
That control factor seems like the defining feature. The sources really emphasize that a LAN is a private network.
It is. There is no outside regulatory body. No one else is controlling the traffic or setting the rules inside that network.
And I assume that total control is what allows for efficiency.
Absolutely. The size is usually under about 5,000 devices, but the speed is the real game changer here. LANs run at a much, much higher speed compared to, say, a huge WAN system.
But the main reason companies build them is it's about the money, isn't it?
It's the economic incentive, yeah.
Okay, so let's unpack that. It's more than just sharing a printer, right? What's the real financial win?
The main thing is consolidating your license assets. So instead of buying expensive hardware like, a huge hard drive or a special printer for every single user,
And just share it.
you share it. But even more important is the software. You can buy one network license for an expensive program and then share it across all the computers. That drastically lowers your per user cost.
Okay, that makes total sense. Centralizing everything is efficient. But that very idea of centralization must introduce a trade-off. What about privacy?
You've hit on it. That convenience comes at a cost to individual privacy. The LAN administrator, the person managing that central server,
You can see everything.
they have the ability to check the personal data files of every single user. So from the user's perspective, it does not offer good privacy from the organization itself.
And the risk isn't just internal, it's external security too. I mean, if that one central server gets compromised.
That's it. Unauthorized users get access to everything. Critical data all in one place. It requires constant, vigilant administration. The high initial cost is one thing, but the ongoing need to secure that one big target is the other major drawback.
All right, so we've hit the walls of the building. The LAN is fast, it's private, but it can only go so far. So what happens when a company needs to connect its downtown office with its warehouse across town?
Now you're scaling up. This is where we get to the MAN, the Metropolitan Area Network.
A MAN covers an entire city, a huge college campus, or a small region.
Exactly. It's much larger than a LAN. It can cover an area from several miles up to, say, 50 kilometers, about 30 miles.
And to cover that distance and keep the speed up, you must need better hardware. We're not just using regular copper wires anymore, are we?
No, not at all. The sources point out that the most common medium here is optical fibers and other heavy-duty cables. They use high-speed carriers to make it all work. Fiber is pretty much essential at this level.
Why fiber specifically?
Bandwidth, mainly, and efficiency. Fiber optics let you send massive amounts of data over long distances at the same time. You need that when you're connecting all the LANs across an entire city.
That simultaneous data flow sounds key. The sources mention specific setups, like a dual bus structure. For the listener, what does that mean in simple terms?
Just think of it like a two-lane highway. Traffic can flow in both directions at the same time. The dual bus means data can be sent and received concurrently, which makes everything across the city much faster and more reliable.
That sounds great for speed, but the downsides of scaling up must be huge. It has to require a lot more cable, for one.
A lot more. A significant investment.
And it must be harder to defend.
That's the trade-off right there. The wider you cast your net, the harder it is to secure it. Because a MAN is spread all over a city with multiple entry points, it's just inherently tough to keep hackers out.
And to visualize this, it might help to look at a slightly smaller version, the CCAN.
Yes, the campus area network. A CAN is a perfect blueprint for a MAN. It's just a bunch of separate LANs, like the science department, the arts department, the admin building, all linked together across a university campus.
So it shows how you bridge smaller, fast networks to create a medium-sized one. Okay, so the moment we start bridging those LANs using public or semi-public technology, we're at the final step up, the WAN, or Wide Area Network.
This is the biggest, most complex, and most expensive type of network. It can span countries or even the entire globe.
So a WAN connects all these individual LANs using, well, everything. Phone lines, satellites, radio waves.
All of it. And while we think of the internet as the ultimate WAN, a WAN is often a private thing, limited to a huge corporation building its own global network.
Right, so a company can share files and make sure everyone, everywhere, has the latest version of a critical document. But let's get right to the big issue. The cost to set something like this up must be astronomical.
It is. And that huge cost is directly tied to massive operational headaches. The complexity just multiplies the maintenance burden.
How so?
Well, you need highly skilled, specialized technicians to run it. And because a WAN uses so many different, often incompatible technologies all wired together, there are just inherently more errors.
And I bet fixing them takes a lot longer.
Exponentially longer than fixing a problem inside one little LAN.
So we've got the highest complexity, the highest cost, the most maintenance. Let's compare it directly back to that secure, controlled LAN. How does all this complexity affect security?
It's a strategic compromise you're forced to make. The sources are very clear on this. A WAN offers lower security than other networks.
And the reason is, what?
You're just not in control of everything anymore. You're routing data across public lines through third-party carriers. The sheer size of it all, the number of devices. Trying to apply one security policy across all of that is incredibly difficult. You are forced to sacrifice tight local security for global reach.
That really brings the whole journey into focus, from your personal secure bubble all the way to this high-risk, high-reward global infrastructure.
Precisely. A LAN is local and high-speed. A WAN is global, complex, and, comparatively less secure.
We've covered networks based on size, but networks are also created for a specific purpose. Let's do a quick tour of a few of those.
Sure. We can start with the most common one, the WLAN, or Wireless Local Area Network.
So a wireless LAN.
That's all it is. It links devices using wireless communication like Wi-Fi within a limited area. It's critical because it gives users mobility. You can walk around the office with your laptop and not lose your connection.
And we can bring that focus right back home with the or home area network.
Right, just a specialized little LAN for your house.
Right.
Connecting 2 or more computers and a printer so you can share files. And it's super common. The sources say something like 15 million homes in the U.S. have more than one computer.
Then you get into the really specialized business stuff like a SAN, a storage area network.
Yeah, that one has a very specific job to consolidate data storage. It's about making huge disk arrays or tape libraries available to lots of servers at really high speeds. It's all about fast central data access.
And we also have the EPN, an enterprise private network.
Which is basically a network a huge business builds and owns itself, specifically to connect all its global offices without having to rely entirely on public infrastructure.
But I think the most important purpose-built network for our listeners, the one designed to solve the security problem we just talked about with WANs, is the VPN.
The virtual private network.
Yes. This is the answer to that global scale security problem.
It absolutely is. A VPN is a private network that cleverly uses a public network, the internet, to do its work. It creates these secure, encrypted virtual tunnels to connect remote users.
So it keeps you safe on, like, public Wi-Fi.
Exactly. It's a technology designed to give you the privacy and security of a LAN, even when you're out on the insecure vastness of a WAN.
That clarity is what we were aiming for today. So if you came here looking for framework, here it is. We started in your personal 10-meter bubble, the PAM.
Expanded to the high-speed office LAN.
Stepped up to the city-scale MAN, built on fiber, and then analyzed the complex, high-cost global WAN.
And we saw how the WAN's scale and complexity inherently compromise that local control and security. But then we also saw how technologies like the VPN exist to try and add that security layer back on top.
Which raises a really interesting final question for you to think about.
We need that global connectivity from a WAN, but we crave the security of a LAN, so how does the simple choice to connect your devices across these huge distances, having to rely on all these different carriers and public lines, create security challenges that are maybe unsolvable at the basic architecture level?
Meaning you'll always need something extra, like a VPN.
Right. What is that permanent trade-off you accept just by connecting your private little bubble to the rest of the world? Something to mull over the next time you hit send.
Thanks for listening. If you found value in today's episode, please subscribe and leave us a review. It helps more people find the show. See you in the next one.
Hey, yo, haven't you checked out our new book yet? Link in description.